Hi guys, it's Mrs. Melson. Okay, I'm going to do 3 separate videos for Chapter 10. Okay, so Chapter 10 is 2 proportion and 2 sample significance tests. Okay, so if we look back on that little cheat sheet I gave you a couple weeks ago or whatever, we've been spending a lot of time on Chapter 9 with mean proportions and means. Now we're going to go through 2 proportions and 2 means. Now if you look, it's very similar. Okay, so instead of comparing our P or mu to a value that we're given, we're actually just going to compare 2 proportions to each other and 2 means to each other. Okay, now I can subtract the one from the other side and say that the difference is equal to 0, which means they're equal to each other. There's no difference. Or I can say one is greater than or less than the other. Okay, I'm going to have to identify two population parameters, okay, in either one, because again, I'm comparing 2 samples together. I'm not going to have like a status quo or a set value, okay? And then when I do my conditions, I have to do random independence and normal for both samples, okay? When we get down to our test statistic and our p-value, we're going to do this in the calculator, okay? We're not going to actually plug in our equation here, okay? And then once we find our p-value, of course, our conclusion will be the same. Okay, so I thought I would describe it to you using these same scenarios that we used when we were talking about differences in means and proportions in confidence intervals. Because again, confidence intervals and significance tests work together. So whatever my conclusion is here, my confidence intervals should be the same thing for my significance test. So what I'm going to do here is I'm going to compare these 2 means, the mean amount of money male students earn during the summer and the mean amount of money female students earn during the summer. So that's going to be my HO, okay? And then I'm going to do a HA to see if they're different. Okay, let me write these out. So let's see our state. Okay, so instead of I'm going to do a mu. Instead of me saying mu equals some number, okay, because I don't have a typical amount of money that college students earn during the summer, I'm going to compare the mu of the males to the mu of the females. So if they're equal, there is no difference. So let me identify U of M equals the true population mean summer earnings for males. Okay, and then mu of F is the true population mean summer earnings for females. Okay, again, I'm not comparing to any standard summer earnings. Again, I'm comparing 2 values from 2 different samples. Okay, and I'm going to use my samples in a second. So for the HA, I just want to know if they're different. Okay, so I'm going to do not equal. So if I reject the HO, I have evidence that there is a difference. Okay, they're not equal. If I fail to reject the HO, then I don't have evidence that males and females earn different amounts of money during the summer. But if you'll notice, if you remember back here, 0 was not an interval. So we do have evidence that there is a difference. So I'm going to have to reject the HO, okay? Because I'm going to have evidence that they're not the same, that there is a difference, okay? So let's see. This was a 90% confidence interval, so I'm going to do an alpha of 10, okay? So I've done my state. All right, so let me do my plan. And again, this isn't a 1 sample t-test. This is a 2 sample t-test because I'm looking at 2 different samples. So a 2 sample t-test. All right, so I got to go through my conditions. And I got to go through them for the males and the females. Okay, so I got to do random, independence, and normal. What is that? That's independence. Let me fix that. For both males and females. And again, this scenario wasn't fully set up for significance test, but I should be okay. Random. Good. There is a random sample. So stated random sample taken. And that satisfies for both males and females. Independence, I'm going to do my 10% rule. I'm pretty sure there's more than 6,750 males, and I'm sure there's more than 6,210 females at this university, at this large university. Okay. And again, I'm always going to assume that unless I'm given information to think otherwise. And of course, students are all independent of each other. And then for normal, thank goodness my sample size is large, so I can say central limit theorem because 675 is greater than 30 and 621 is greater than 30. Okay, so not too bad. I just kind of had to do double duty with my condition. Okay, so now when we do the do, I'm actually not going to go through and plug everything in. Okay, instead, I'm just going to run this in the calculator. Okay, so when I run my two sample t-test, there we are, two sample t-test, I'm just going to go over to statistics, of course. I'm just going to put in all my values. Now, I listed the males first, so they're going to be all the one information, mean, standard deviation, and sample size. Female, I listed second, so they're going to be the number 2. Okay, so I'm going to come up here. The mean for my males was 1884.52 standard deviation. Sample size. For my females, 1037, 6, and my sample size is 621. Okay, the symbol of my Ha is still not equal to. Don't worry about pool. And I'm going to do calculate this time because I'm going to write down, I need my t-score, my t-test statistic, my p-value, and my degree of freedom. Okay, so here I'm going to note my t-test statistic or my t-score, 7.807. My p-value, 1.2 times 10 to the negative 14th. Okay, that is a tiny number. I'm not going to write 13 zeros, so that is pretty much 0. And I'm going to note my degree of freedom because we should always, whenever you're dealing with means, we should always note the degree of freedom. Okay, so now I can do my conclusion. All right, so I'll do my conclusion. I'm going to test my p-value against my alpha. Well, I barely even have to look at that because 0 is less than anything, right? My alpha is never negative. So that is true. So my conclusion will be the p-value 0.0 is less than alpha. And it is statistically significant. At the 10% alpha level. So I can reject the HO. Okay, so if my P is low, I'm going to reject the HO, which means I do have evidence that the true population mean summer earnings for males is different than for females. Okay, I do have evidence that the true population mean summer earnings for males is different or not equal to for females. Okay, and that's pretty much exactly the same conclusion we came to when we did our confidence interval. There is evidence of a difference in summer earnings between males and females. Okay, now from our confidence interval, we're able to come to the conclusion that males typically make more money. Okay, because of the way we set it up. Here we just know that males and females do not make the same amount of money. Their true population mean earnings are different. Okay, so this is what a two sample t-test looks like. Again, we don't have a value to stick in our HO and our HA. We are simply comparing two populations from two samples, okay? And again, the do we're going to do in the calculator, okay? Double duty on the conditions. Conclusions exactly the same. Okay, all right. I hope this was helpful. I'll do another one for proportion.